Hey guys, welcome to your Chapter 7, Lesson 2 notes on multiplying powers with the same base. By the end of the day, you'll be able to multiply powers with the same base. And just remember, the base, when we're talking about base is the guy at the bottom. In this case, the base would be A. Okay? And what happens here is, let's say you have A, multiply it by itself m times. So you have A times A times A, that's m times. Okay, and then you multiply that times A times n. Sorry, not A times n, but A times itself n times. So you have here, you have an m number of A's and you have n number of A's. So when you multiply them together, you get a total of m plus n, because it's A times A times A times A, m times, and then A times A times A, n times. So it's A times A times A times A times A times A times A, whatever that is, m plus n. So that's where you get this is A to the m plus nth power. So that's your rule. If you have A to the mth times A to the nth, that's A to the power of m plus n, together like that. For example, you look here, these 12 guys. Here our base is 12. This only applies if they're the same base, by the way. And then our powers here are 4 and 3. So that's the same thing as 12 to the 4th power. Sorry, 12 to the 4 plus 3rd power. So that's 12 to the 7th power. Don't believe me? Find out what's 12 to the 4th power, what's 12 to the 3rd power, multiply them together and say, ooh, that's the same thing as 12 to the 7th power. Boom. Hey, look, we have this again. It's the same base. We've got negative 5 to the negative 2nd, and to the 7th power. Coolio. So you get, that's negative 5 to the negative 2nd plus 7th power, but since it's negative, we put it in parentheses. Cool. So that gives us negative 5 to the negative 2 plus 7 is 5. And we're all set. Nailed it. Isn't that great? That's great. Okay. So when we go back to simplifying expressions, remember earlier that to simplify expressions, we cannot have negative exponents. And now I'm giving you guys a new rule. You can have each base only once. So you need to combine your bases. And then from there, you need to simplify your exponents. Remembering that we're not allowed to have negative exponents. Not allowed. Okay. So let's look here. What kinds of bases do we have? Well, we have 4 times 9, so I'm going to multiply them together first. We also have z's, so that's, I guess I'll just do this way. 4 times 9 is one idea, and then z to the 5th and z to the negative 12th power. That's a whole other idea. But remember, you simplify those exponents by adding them together. 4 times 9 is 36, so that gives us a 36 out in front, times z to the power of 5 plus negative 12. I was just going to say that's 5 minus 12. 36 stays the same. Z to the 5 minus 12th power is the negative 7th power. Oh no! Kind of a negative 7 exponent? Yuck! But remember, man, I used all the wrong colors here today. How about we make them red? Haha! Okay. Kind of a negative exponent? Yuck. But remember, that negative is the same thing as a fraction bar. So this is the same thing as 36 times 1 over z to the 7th power. Or for those of you who like to skip steps, you can say that's just straight up 36 over z to the 7th power. Yay! All set. And then we scoot them over so we don't encroach on B's territory. got it. So we combined the bases, we combined similar ideas, and then we simplified our exponents like that. Okay. Ooh, look, we have so many different things going on right now. We've got our normal numbers out in front. We got them coefficients. We have C, and we have D. So we're going to combine those guys all together. First by multiplying -4 times 7 times 2. And then by multiplying C times C to the -2nd. And then multiplying by D squared. Remember, we're allowed to scoot these guys around because of the commutative property of multiplication, which tells us we're allowed to rearrange to move them around. -4 times 7 times 2 is -56. Here we've got C to the first power. Oh, look at that hidden invisible 1. C to the power of 1 minus 2. And D squared. Cool. 1 minus 2 is -1. But remember to have a negative exponent. That's the same thing as 1 over C to the first power. But you guys know by now that to the first power you don't even need to write, so I'm just going to leave that there. So that's the same thing as -56 times 1 over C times D squared. Again, you can treat these guys like their own little fractions. So we'll adjust them for height. Multiply all the way up on top because it's -56 D squared, and on the bottom C. In this case, I put my negative up on top of the fraction. If you don't like to do that, you want to put them down here, you can. Just a word of caution, this could sometimes blend in with the fraction bar. So I sometimes put them up there like that. Cool, huh? Okay, that's great. But we've been working with like whole number exponents. What happens if we have a fraction like this? If we have a fraction like this, we need to work backwards. A fraction here, let's actually go here. When we look at a number like 12 cubed, 12 cubed means you take 12 and you multiply it by itself 3 times. You have 3 12s present here. That's what the exponent means. So here, the question is saying, hey, you know what? 81 is something, whatever it is, 1, 2, 3, 4, to the 4th power. So we need to figure out what that something is. We've got something to the 4th power equals 81. What is that thing? So we're going backwards. It's 3. So that's fun. 3 times itself 4 times is 81. So 81 to the 1/4 power is 3. Cool. Now here, let's look at -27 to the 1/3 power. I guess I should have put that this way, but that's not going to change the problem. So we're looking for some number when multiplied by itself 1, 2, 3 times equals 27, and then we're going to put a negative out in front of it. So we'll do that afterwards. So what times itself 3 times equals 27? It's 3 again. Sorry, I spoiled it. That was lame. I should come up with a different answer. But it said, what is negative that number? Well, that would be -3. Yay. So now we need to simplify each expression. Think of it this way, because that, straight up, guys, look at this. That's gross. Don't think of it as 3/2. Think of this as 25 to the 3 times 1/2 power. Actually, I'm going to switch it. Think of it as 25 to the 1/2 power times 3. Does that help? Well, we're gonna jump in. Because that's the same thing as 25 to the 1/2 power times 25 to the 1/2 power times, oops, I missed, 25 to the 1/2 power, or to the power of 1/2. And 25 to the 1/2 power, well, we're trying to find something times something equals 25. That was twice. It's 5! Yay! Okay, so that's 5 times 5 times 5, which is 125. Ta-da! One more. 2/3. Okay, well, same thing. This is the same thing as 27 to the 1/3 power times 2. That thing's squared. Okay, so that's going to be 27 to the 1/3 power times 27 to the 1/3 power. Guys, check it out. We learned last time that 27 to the 1/3 power is 3, but they asked for a negative, so we made it negative. But this time it's positive. So we know 27 to the 1/3 power is 3, and 3 times 3, 9. Ta-da! That's it. Okay. So to simplify expressions, make sure you have bases. You combine your bases. Your exponents are all positive. They're not in fractions. And you can add exponents together. But if you do, it is a requirement that you have a great time on your homework.